9 RK Bali. If the temperature is 12 degrees Celsius, pressure altitude is 10,000 feet, what is the density altitude? Simple. Density altitude equals to pressure altitude plus 118 into ISA deviation. Pressure altitude is 10,000 feet given to you. ISA deviation. Outside air temperature is 12 degrees Celsius. ISA temperature at 10,000 feet equals to how much? 15 degrees minus 2 into 10. 15 minus 20, which is minus 5 degree Celsius. Minus 5 degree Celsius. Okay. So that is your ISA temperature supposed to be at 10,000 feet. ISA deviation equals to outside air temperature minus ISA temperature. So outside air temperature is 12 minus ISA temperature is minus 5. So 12 plus 5 is equal to 17 degrees Celsius, right? So yeah, so density altitude will be equal to pressure altitude 10,000 plus 118. ISA deviation is how much? It is 17 degrees Celsius. 17. So 10,000 plus 118 into 17 equals to how much? Use your calculator. 2006. So 10,000 plus 2006 equals to 12,006. The closest value is option A. Option A. Next. Question number 40. If pressure altitude is 0 feet and ambient temperature is 10 degrees Celsius, what is the density altitude? What is the density altitude? So, density altitude equals to pressure altitude plus 118 into ISA deviation. Pressure altitude is 0. ISA deviation, let's find out ISA deviation. Now outside air temperature is 10. ISA temperature is 15 minus 2 into 0. 15 minus 2 zeros are 0. So 15 minus 0 is 15. Right? So ISA pressure altitude at 0 feet, which is mean sea level. So according to ISA temperature at mean sea level 15, if you don't know, you can calculate it like this. ISA deviation outside air temperature minus ISA temperature. Outside air temperature is 10. ISA temperature is 15. 10 minus 15 is minus 5 degree Celsius. Let's put the value here. Minus 5. So plus minus minus 118 into 5 is minus 590 feet. So correct option is option B. That means density altitude is below pressure altitude. Question 41. If elevation is 1000, QNH is 1025, QFE is 99167, what is the pressure altitude at the field? Pressure altitude is measured from what datum? It is measured from 1013 datum. Let's draw this diagram. So your airport is above mean sea level at an elevation of 1000 feet. QFE 991, let's take it 992, QNH 1025, and now we have to calculate pressure altitude of the airport, of the airfield. So pressure altitude is measured from 1013 datum, standard pressure setting 1013. Lower pressures will exist on top of higher pressures. So 1025, 1013 and 992. So let's calculate this. So we know the total elevation is 1000 from here to here, and we are told to find pressure altitude which is from here to here. So from the QFE datum to standard pressure setting datum. Okay, that is what we have to find. Now when we know the two pressure values of the two pressure levels, we can calculate the difference between them and convert that difference into corresponding altitude. So let's write it down. Pressure change is equal to 1013 minus 992 is 21 millibars. Now 1 millibar is equal to a height change of 30 feet. Therefore, 21 millibar equals to how much height change? It will be equal to 21 into 30, which is equal to 630 feet. So this is 630 feet. 630 feet. So pressure altitude of this airport is Charlie. 630 or closest option 640 feet. Okay. Any doubt? So step 1, draw the diagram. Step 2, label that. An airport was given. The elevation of that airport is okay, is useless here, but still elevation is 1000, measured always from QNH or mean sea level. QFE 992, QNH 1025, pressure 1013. Okay, so we were asked to find pressure altitude, so which is pressure altitude always starts from 1013 datum up to the airport. So that is how you find it. Question 42. Density altitude. What is density altitude? Three statements are given to you. You have to check the option containing correct statements. Statement 1, the elevation at which the prevailing density occurs in the ISA. So elevation is the right word. Density, ambient density is the right word. ISA. So statement 1 is correct. Statement 2, pressure altitude at which prevailing temperature occurs in the ISA. Pressure altitude is correct. Prevailing temperature, this phrase is not correct. ISA is correct. Okay, but this prevailing temperature is not what we want. We want prevailing density. So statement 2 is wrong. Statement 3, pressure altitude at which prevailing density occurs in ISA. So pressure altitude right, ISA is right, and prevailing density is also right. So statement 3 is correct. So out of these three options, the correct option containing statement 1 and 3 is option C. So statement C, option C correction is the correct option. 43. Pressure altitude is 29,000. Outside temperature minus 55. What is density altitude? Write the formula. Density altitude is pressure altitude plus, now I am taking 120 into ISA deviation. ISA temperature at 29,000 is 15 minus 2 into 29. 15 minus 2 into 29 is how much? 58. 15 minus 58 is minus 43. That is, ISA temperature must be minus 43 at 29,000 feet. But what is the temperature? Minus 55. It's colder than minus 43. So ISA deviation is outside temperature minus ISA temperature minus 55 minus of minus 43. So minus 55 minus minus plus 43. So minus plus minus 55 minus 43 is minus 1 2, that is 12 degrees Celsius. That is the difference. And minus indicates colder than the given value. So 29,000 plus 120 into minus 12. 29,000 plus minus minus 120 into 12, 1440. 29,000 equal minus 1440 is 27,560 feet. So correct option is, or the option containing this value or any other value closer to this will be the correct option. So density altitude is 27,560 feet. Next, 44. Outside temperature 35, pressure altitude 5,000, true altitude, not density altitude, true altitude. So nice. So when the statement contains temperature factor, that means we have done this questions many times in the questions in which during when I solved this questions from Oxford Altimetry. I will definitely put the link of those lectures in the description box. I also suggest that after watching this video, watch those videos also, in which we have repeatedly solved questions in which we had to find true altitude from the temperature, from pressure. Okay, so that will be very useful for you. But those who have not watched that and doing this type of sun for the first time, look at this, look at how to do this. A simple theory I will tell you is that when temperatures are warmer than ISA, your true altitude will be more than indicated altitude. So currently indicated altitude is 5,000. If temperature is warmer than ISA, we will find that out, ISA deviation. True altitude will be more than indicated, which is 5,000. If temperatures are colder than ISA, so your true altitude will be less than indicated altitude. Okay. So the formula, the difference between true altitude and indicated altitude formula is, so true altitude difference equal to, the formula is 4 degrees Celsius into ISA deviation into 1000 feet into 1000 feet. So 4. Now we have to find ISA deviation. 1000 feet is per 1000 feet. Okay. Per 1000 feet. So here we have 5000 feet. So the value pi should be written there. So ISA deviation. Now outside air temperature is plus 35. ISA temperature at 5000 should be plus 5. Right? Plus 5. So what is ISA deviation? 35 minus 5, which is 30 degrees Celsius, plus 30 degrees Celsius. Let's substitute the values. 4 into 30 into 5, which is 600 feet. So that is the true altitude difference. That is the true altitude difference. So difference is how much? 600 or plus 600 feet. So that means your true altitude will be, indicated altitude given in the question plus the difference of 600. So 5000 plus 600 is 5600 feet. So true altitude is 5600 feet. So when there is a temperature given in the question, you have to use this formula. 4 into ISA deviation into per 1000 feet, and then substitute the values. When temperatures are warmer than I said true altitude will be more than indicated. So warmer temperature, we found that the temperature is warmer by 30 degrees Celsius. Therefore, our true altitude has become 5,600 more than indicated altitude of fresh altitude of 5,000.